we're going to look at adding vectors, orthogonal vectors. Now, orthogonal looks like a pretty fancy word, but all it means is at 90 degrees too. So at 90 degrees. So I have two vectors that are orthogonal or at 90 degrees to each other. Although orthogonal, if you talk to the math types, it means a little more than at 90 degrees, because after you get past 3 dimensions, you get into n dimensions. 90 degrees doesn't make a lot of sense. What's at 90 degrees to x, y, and z? Well, I don't know. So we use the word orthogonal for that. It has a very specific definition. I just want you to get used to that word. For our purpose, it means 90 degrees because we're not going beyond 2 dimensions. So let's start by defining which direction is which. So we're going to have north pointing up, and we have two vectors here that we're going to add. And we started with the tail of this vector here going to there, and to find their sum, we're going to put the second vector with its tail at the tip of the first, pointing down. So if we decide to sketch the result of these two vectors, adding these two vectors, it's simply we start at the tail of the first one, end at the tip of the second one, and that's what we get, and there's my result. However, we want to quantify that. We want to use some numbers, and we want to represent it appropriately. So let's imagine that this one is 13 meters, and the direction is east. And this one is 15 meters, and the direction is south. Now, if I'm looking at these two and I say, well, what's the magnitude of the resultant? Well, there's the resultant vector. We'll call it d for displacement. And we'll put these two signs to say, hey, I'm just interested in the magnitude. What is that going to be? That's my first step. So my first step will be to figure out basically how long this line is. Well, go back to your grade 9 math, and you can figure out that what that magnitude should be. We're going to use the Pythagorean theorem, and I don't need you to write anything down. You can pull up your calculator, and you can do that calculation all on your own. And so we say, well, it's 13 squared plus 15 squared, and then we take the square root of that. So 13 plus 15, whoops, what did I do? I didn't, let's start over, clear. 13 squared plus 15 squared, okay, what does that equal to? 394. And what are we going to do? We're going to take the square root of that, and so we get 19.84. So if I round that to 2 significant digits, what is that? That's going to be 20 meters. So the magnitude of that displacement without the direction is 20 meters. And that's the first part of my answer. But I'm not done. Remember, when we're dealing with vectors, we also need a direction. So I'd like to describe this direction, the direction as vector. I can describe it in terms of south, but I think I want to use this angle here. Why? Because it's already part of the triangle. I could use that one, but for me, I think it just makes more sense to use an angle that's already shown. So it's this one right here, alpha. So let's remember our basic trigonometry. Tangent of alpha is equal to opposite, which is 15, over adjacent, which is 13. And we don't need to worry about direction or anything with these, okay? Just use the magnitudes when you're finding that angle. You'll look at your diagram to figure out what the direction is once you're done. So we know the tangent of alpha is 15 over 13. So therefore, alpha is equal to the inverse tangent of 15 over 13. So once again, you want to pull up your calculator and figure out what that is. So you go 15 divided by 13 equals, not sure what happened there. Let's try that again. 15 divided by 13 equals, so we get this big number. I'm going to make sure I'm in degrees. Then I press inverse tangent, and I get 49.08 degrees, so that's going to be 49 degrees. So my final answer for the result of this addition is going to be my displacement, which is the sum of my two vectors, is going to be 20 meters. And I need a direction. Why? Because it's a vector, and my direction is 49 degrees. And where did I start? I started east and I went south, so it's 49 degrees south of east. And it's just as simple as that.